It's a war zone. She would try anything. She would like drop a mark in the water. No, not bad,
Every time he sweat stains.
But it'd be like down to here.
Except it wasn't a sweat stain, it was actual sweat.
So mean though. I was so mean to him. One time he was there, why do you hate me? And I'm like, I just don't like you, dude. It was just there. Hey, quietly. So check your answer. So much of a practice test.
All of it?
I'm going ugly. Yeah. But you didn't ask how many you got right. How many did you get right?
I guess I'm all of
I missed every single
Why do you send me wine check? That's I have to try. Yes, I need
conscientious. Things that are actually more important than being smart. Like, have you heard this study? What's that? Oh yeah, let me tell you a story. Yeah, you gotta hear this one. Yeah, wisdom. Listen, hey, you gotta hear this one. Listen close.
Yeah, that was terrible.
Hey, look up. Hey, come back again. Everyone put your phone away. Everyone put your phone away. I'm thinking seriously implementing a system. Just want to watch your face and see how you feel about this. Seriously implementing a system in all my classes where I kind of watch, and as long as you're not like on your phone during class and you're paying attention during class, then at the end of class I give you like a special coupon that says, please come ask for help as much as you want. I will stay as late as I humanly possible to help you. And then I have another set of coupons so that's the carrot method, right? I got the stick. Everybody know what I mean by carrot and stick? Yes. No? Old-fashioned analogies, right? So the analogy is that if you have a mule and he's pulling your cart, you're trying to get him to go, you got two methods you can use. You can just beat him with a stick until he goes, or you can put a carrot out in front of him and try to get him to follow the carrot. Positive versus negative reinforcement.
Beat him.
Forget that. I'm just too old. Apparently all the analogies don't mean anything to you.
Well, I get it now.
Beating or not beating?
So then the other coupon I have, Chad, is this. At the end of class, if I noticed that you were on your phone during class or you just weren't paying attention at all, I give you a second coupon. I'm not going to help you for 1 second after school.
Oh, God.
Does that make sense? Is that a fair thing to do?
Yeah.
Is it not fair?
Yeah.
Yeah, if you come to class and you don't take advantage of the time in class, why should I give you any help after school? Is that fair? Just checking. If Jackson says it's fair, I'm good. I don't need to ask anybody else. All right. He knows what's fair. Very fair-minded man, in my opinion. I have great respect for Mr. McChesney. All right. Anyone have any question you would like? Okay, all day today, I'll answer as many questions as you want. After that, I'll just give you the new practice test. Open.
So I have to actually number 4.
Yes. Oakley, me and you, bro. We did the same. All of us.
Oakley, 4 is a popular choice.
Yeah, go for it.
We've had the same questions we've had the same questions for like 4 days in a row.
Very good. Dude, that's cool.
Relationship goals.
Look up to there. Sharpen. Get back.
Although when she's done after she gets you, don't see her on certain looks like when you're talking, you go like this.
Please memorize. If you don't have a graph, a sign chart is the replacement. If you have a graph, please don't use a sign chart. So I left out the rest of Danica's chart because I don't need it. I'm trying to figure out when F is concave up. So all I need is this relationship. Therefore I know I need a sign chart of F double prime. We have a question with there. Equal. So here we go. One warning for the test. When I don't create packets randomly, I don't do it quickly, I take a long time to do it. So I spent many, many hours, probably 4 or 5 when I created that originally, looking through many, many problems, trying to find exactly the right problems to put on our practice test, to give you just the right tips, clues, practice to be successful on the real test. So if you skip any problems on the practice test, you're skipping something valuable. There's nothing extra. I was trained as an engineer, so I'm always looking for efficiency. It's really easy to give someone 300 questions, say, here's the practice test. I try to cut it down as small as I could possibly make it and still make it valuable.
You don't have to factor.
I would not. The reason we're factoring is to make the sign chart. It's actually easier to take the derivative again if F prime is not factored. Does anyone have any questions to that? So now I do the sign, factor F double prime now.
We don't have to factor up the
That's what I did wrong.
Yeah, don't factor F prime. It makes it harder. It's not illegal, but it is harder. The rule is this, Derek. Finding a derivative is easier if the function is typically non-factored. Finding the sign chart, you have to have it factored. So, there you go. So now I can build the sign chart. So this is going to be 0. So when x is equal to 0, 60 times 0 is definitely 0. How many questions so far? There are 2 values of x which will cause this to equal 0. This is shown up in several homework problems.
Positive square root of 2, negative square root of
Perfect. I was going to say square root of 2 tickets, but that would not be very favorable. So we'll say 3 instead. Nice to know. Now you just test. So let's see, if I plug in x equals 0, 0 squared is 0. Subtract 2 means these are negative. I need something larger than root 2. Root 3. 2 works. 2 squared is 4. 4 minus 2 is 2. So this is all positive. Plug in and say negative 2 squared. And negative 2 squared is positive 4. Minus 2 is positive. I test the 60x. It's going to look like this. Make it very colorful today. Yeah, a little green looks nice. I'm going to say do not. Please memorize this do not statement. Do not look at a sign chart of F double prime and make a picture of F. Do not ever try to make a picture of F based on a sign chart of F double prime. it can lead to mistakes. Don't ever do that. It's very common to take a sign chart of F prime and make a picture of F. That works really nicely. Or a sign chart of F prime and make, sign chart of F double prime and make a picture of F prime. Don't make this big jump. Any questions? Like really memorize that. Don't do it. You good? Okay. So we're good to here. This is negative, positive, 0, negative, positive. It says, when is the graph concave up? So you simply write, let's see here, new color, red. So F is concave up, where F double prime is positive, which would be negative root 2 to 0. And then from whenever x is bigger than root 2. Question? Questions from anyone? Wait if you need to stay here so you can take notes. We have a different question. Please, Betsy.
Number 15.
15? You need to stay here still? 15. Good news is so far A1 has asked totally different questions, so the file I'm building that I'll post online on my website, you'll have more questions and probably get asked in class. That's to your advantage.
And I'm having fun too.
That one I think I actually did. Hold on a second.
It's this body of like these two little like 10-year-olds who's Hillary Clinton on the front of Halloween. They like knock on the door, they're like, the girl who's is like, Donald Trump, he's like, yes I am. And then the girl's like, Hillary Clinton. Shut up. Anyway. It's so
First thing I start out with is Danica's chart. Danica Wright, she's a very nice, very good.
There you go.
Oh.
Very good.
That was the last name.
Oh, God.
Sorry, she would have been a great wife, but she's taken.
That's okay. I can still love someone else.
Sure.
What's the last name? Okay.
So F has a relative maximum F change increase, decrease. So again, if I don't have a graph, I do a sign chart. So I do a sign chart of F prime. Second function, multiply by the derivative of the first. That's the first function, multiply by the derivative of the second. Another question. Keep going. would have a question to there. We'll keep going. Second to catch up in your notes. Questions from anyone? Okay, to do a sign chart of F prime, I have to have factors. Please have that memorized. Can't do a sign chart unless you have factors. So I've got a factor F prime. So I'll pay someone multiple tickets. Every time they answer one of my questions, I'll give you a ticket for as long as you keep answering my questions. I just need a volunteer. Let's go, Landon. So Landon, when I look at F prime, I can only factor if I see a term plus a term plus a term, etc. So do you see two or more terms being added to create F prime?
Yes.
Good, that's one. How many terms do you see that are being added to create F prime?
2.
Perfect. So there's this term and this term.
Yeah.
The first term is made up of factors, which multiply together to create the first term. How many factors are there in the first term?
Just 1.
Good answer, but there's technically 2.
Yeah.
It's x minus 3 and x minus 3. Would you agree?
Yes.
Good. How many factors make up the second term?
3.
And what are they?
X minus 2, 2, and x minus
Good, 5 tickets so far. So which factors are in both terms?
3. X minus
So pull that out. That's 6 so far. So what factor remained of this term?
3. X minus 3 still.
Good. And because I started with 2 terms, within the factoring here, I've got to have 2 terms. So plus, what factors remain here?
X minus 2 and 2.
Nicely done. That'd be 7 tickets. Good work. Another question. Somebody else who'd like a series of tickets?
Brad, just ask you a
There you go. Oh, Brady, please.
Would
yeah.
you distribute that too?
Nice, stay with me. And then second question, Brady, is do I need these parentheses, yes, no, why not?
I feel like yes, because it's still a factor, right?
It's not, no, your answer is just fine, but that's not the reason you want to think about parentheses. Look here and tell me this. The parentheses indicate that something's supposed to be done to what's inside. So these parentheses are telling you that what's supposed to happen to these things.
Oh, they're supposed to be, or the two is supposed to distribute.
Nice, the 2 is supposed to distribute. So do these parentheses indicate that anything's supposed to happen to this?
No.
No, that's why we don't need them.
Okay.
Does that make sense?
Yeah.
3 tickets. So then I'd have this. This would distribute.
2x minus 4.
Because this was plus, I don't need the parentheses any longer. I didn't need to distribute a negative.
Okay.
Then we have F prime. Brady, what does this become?
Comes. Is it 3x?
Don't make it harder than you're making it.
It's 3x.
There you go.
Minus 7.
There you go, perfect. You might have 2 more for Brady. Let's have a question.
Go Brady.
So now we make a sign chart. Actually, I don't want to keep going if it's boring. So just raise your hand, don't keep going, otherwise we'll go to the new problem. I'm going to study this one. Okay, so sign chart. So let's see, x equals 0, no, x equals 3. x equals 7/3. 7/3 is less than 3. Question asks for relative maximum on F. So I write on the paper. F has relative max when F changes increase to decrease, or where F prime changes positive to negative, which is at x equal 7/3. Tara, raise your hand. Please.
So on number 19, it kind of pretty much asks the same question. So it's not F prime, but then the factors is zero.
Anyone else have a question? Please. Different one. Anyone else have a question? Please, Jeff.
So the reason you started at, just like I'm trying to clarify, 7/3 is because that's where one of the factors becomes 0?
Yeah.
Like, are you starting where each one becomes 0 and kind of?
Always, always. Listen to Chad, listen, 3 tickets. When you're building a sign chart, Chad, everyone else, 2 key things. You have to list the factors which multiply to create F prime, or the factors which multiply to create F double prime, or whatever.
Yeah.
Then you've got to, next step is to figure out what value of X causes each factor to equal 0. Make sure you place those values some distance apart to prevent a mistake. Now here's something that can help, Chad, everyone else. If you look at this and you just can't kind of, how do you say, mentally compute the value, just set up an equation and solve that. So just write down 3x minus 7 needs to equal 0. So 3x needs to equal 7. Oh, there we go. X needs to equal 7.
And it's because like it's not x. If you had like a square, like x squared, you couldn't do that.
No.
Then it would be fast.
Good question. Hold on a second.
Does that make sense?
Yep. So here's one that causes people a lot of trouble. This is a really good question to ask. 1 second. So here's some that cause people trouble. Just other examples. Okay, I've seen a factor like this before. So I set up the equation. X squared minus 3 needs to equal 0. That means x squared needs to equal 3. So we take the square root of both sides. But you have to remember, when you take the square root of both sides, there are 2 possible results. Either root 3, or x could also equal a negative root 3. So there'd be 2 places, 2 values of x, which will cause this factor to equal 0. Does that make sense? Please. Also a very common example. Right there, I just stopped because I remember, look, there's only 3 possibilities for x. Positive numbers, negative numbers, or 0. If you take a positive number squared and add 3, is the result positive, negative, or 0? Positive. If you take a negative number squared, add 3, what's the result? Positive. If you take 0 squared, add 3, what's the result? So this is simply always positive. There is no value which will cause that to equal 0. Everyone, look at this. This has got to make sense to you because on the test this will happen. Like they'll design some problem where you run into a factor like this. You can't be fooled into thinking that the sum value of x makes this 0. It doesn't. It's just always positive.
So if we saw one like that, like that one, it would always be positive.
Yeah, it's an easiest chart. It's just always positive. Just like if you see e to the something, you know, e to the x, or e to the negative x, or e to the 3x, or e to the x plus 7, whatever. Always positive. No, it's not dumb at all. So it's really simple. Let's take e to the negative x. Give me some number for x. 4. But another way to write e to the negative 4 is simply 1 divided by e to the positive 4. And since e is about 2.7, you tell me, will this be a positive or negative value? Positive.
Okay, what about there's like negative, like, okay, that's always positive. So if it's a positive x, if it's either a positive exponent, then it's a positive anyway.
Right, but if it's e to a negative exponent, it's equivalent to 1 over e to the positive exponent.
Okay.
That's why e to the anything is always positive. The last possibility, Derek, would be this. Good question.
Yeah, well, isn't any positive number to anything so positive?
Now listen to Deborah, please. E is just an example of a positive number, 2.7. So any positive number to any exponent is always positive. And they will not give you this, a negative number to an exponent, because this goes crazy. Like really, depending on the exponent, you get a positive value, sometimes you get a negative value, just jumping all over the place. So I've never ever seen an AP question where you had to do a sign chart or something like that. Question? Please.
So what would you do in the case that you did have the x minus or x greater than 3, where there's two values x and 0?
So basically, your sign chart for this would look like this, Chad.
So just x to 0.
You're good. And then you test to see what's going on.
Okay.
Everybody else?
So if you have like x plus 2 to the 4th power, you basically just ignore the 4th power when you're making a sign chart, you just do minus 2.
No, you have to pay attention to the power. Let me just, go ahead, keep talking. You're doing
You
great.
do the like 4th root. Like I don't know how to find the 0.
You're okay. Let me flip to a new page and I'll talk about it. It's a really good question. Hold on. Some more examples of sign charts. The first part of what you said, I understand better what you're saying now, Lexi. The first part, when you said ignore, I misunderstood your meaning by saying ignore. What you really meant was, if I'm trying to find out the value of x which causes this to equal 0, yes, ignore the power. Yeah, just ignore the power, and what's the value?
So it would be positive.
Just positive 2. So this sign chart's going to look like this. At x equal 2, this is equal to 0. Now you do have to pay attention to the power when you're testing. Yeah, because if I come over here, so Lexi, give me a number that's less than 2. So what's 1 minus 2? And then negative 1 to the 4th is 1, so positive. So the 4th power is important when you're doing that.
Okay.
Then you come over here 3, like so. That make sense?
Yeah.
You could have also done this, Lexi, it worked just as well. you can say x minus 2 to the 4th needs to equal 0.
Yeah.
But to solve for x, the first thing you've got to do is take the 4th root of both sides. That's probably more confusing than it's worth.
Well, that's what I was doing too.
Yeah, the 4th root of this is just x minus 2, but the
That's what I
4th root of
think
0 is just
kind
0.
of- Yeah. Ignore the-
That's all.
Let me find it.
Yes. Please. Right. So it'd be good here. These were really good questions. Nice. 19. Someone asked for 19 last period, so I'll show you the steps. Please,
So you factor out then.
you have to factor.
I did, you bring up a 3, I just noted 0.
Yeah, you have to factor this.
Okay, that's
In fact, let's do that together. I'll erase this and start over this part. Okay. Getting to here is pretty straightforward. People get stuck here. The AP test writers are very good at creating problems that cause you to get stuck. So we're going to do a little ticket fiesta. Here's how the ticket party works. I'm going to ask a whole bunch of questions. Every single question is worth 2 is too regular. How many were 4?
7.
4 is good.
30. 30.
You're not in power, Oakley, you chose.
I didn't say 4. No.
I heard 4.
Who said 4?
I heard 4.
I'll say 4. No one's saying 4.
You can choose. I'll do like your parents, right? You can choose. You can have 4 or 2. Which would you like?
I like
4.
Okay, very good. 4.
Neither.
So here's how the game is played. I ask a question. If you know the answer, just raise your hand. If you're right, once the answer is revealed, you get 4 tickets. There's a whole bunch of questions that have been asked, so this will build up very quickly. So the first thing is this. We need to factor this. We still have the 3. Okay. You have to, look, you've got to always recognize quadratics. This technically is not a quadratic. A quadratic would be 5x squared minus 4x minus 1. But this pattern is so similar to a quadratic that the method still works. Can you just be honest with me? Can you basically see what I'm saying when I say this pattern is awful similar to a quadratic pattern? Does that make sense?
Yeah.
Okay. So here's how, now listen. If you, oh, go ahead, please.
So like, this is probably like, so if it was like, let's say it's 5x to the 8th, minus 4x to the 4th with that minus 1, would that be like?
That would also work. Yeah, it's perfect. No, that's perfect. That is perfect. That's the 6, no, it's perfect. I've never seen them ask that, but it's great, it's perfect. Okay, hey. Now look, if you have learned in another class a different way to factor than what I'm about to show you, please keep using that method. It's perfectly fine. I'm just showing you, okay, my experience was this. I learned other ways of factoring, and I would use them for the unit on factoring in, say, Algebra 2 or Secondary 2 or Secondary 3 or whatever. And then I would never use them again. And so I forgot those methods. Okay? The method I'm going to show you, I've never forgotten. Like it's just too easy to remember. So here we go. Here's my method. Everyone who knows the answer to this, please raise your hand. When you're trying to factor this, the first term you look at is this one, or this one. Raise your hand if you know. When you're trying to factor, should you look at this term, or this term? 4 tickets if you know. Which one should you look at first? Alyssa. 5x to the 4th. How many knew that? 4 tickets. So somebody, again, everyone now, what multiplies, hey, it's got to be kind of symmetrical here. What multiplies to make 5x to the 4th? Raise your hand if you know. 4 more tickets. What multiplies to make 5x to the 4th? Maddie?
5x squared.
Maddie says 5x squared and x squared. How many agree? Good. Next thing you got to remember, do I put the 5x squared and the x squared here and here, here and here, here and here, or here and here? Who knows? Where does the 5x squared and the x squared go? like when you're factoring. Write them down. Tara,
5x is going 1, and then, sorry, 5x squared and then x squared.
so how many knew that before I wrote it? Hands up. 4 more.
Yeah.
Okay, next. Oh, please.
So instead of doing 5x squared, could you just do 5 and x to the 4th? Or would that?
Technically, yes, but it makes it harder.
But then you just have to do it.
Yeah, it makes it worse. We really want to do factoring in this pattern. Nothing wrong with it, though, just a pattern that works best. Good answer. Good question. Okay, next one. Hey, next one. Do I focus, I've taken care of this term. Should I focus on this one, or both? This is my method now. You gotta read my brain. Like, what am I thinking? What do I focus on? This is the method I found to be best. What do I focus on? 4 tickets. This one, or this one? Just an interesting break. Good ticket, 1 point for trying.
No. Dang it.
Sarah. I always focus on the last.
Sarah.
4 tickets, I always focus on the last. So Sarah, I just follow up. What multiplies, I do not focus on the negative at all. Just, what multiplies to make 1? 1 and 1. 2 more for Sarah. So the 1 and 1 have to go here, there's nowhere else to go. Okay, now you just start multiplying, but don't pay attention to any signs. So, raise your hand if you know, when you start multiplying, some term shows up here. Raise your hand if you remember how to multiply, and you know what term is going to show up here. Raise your hand if you know what term is going to show up here. So Jacob?
5x to the 4th.
Hands up if you knew that. We're just using the FOIL method that you all learned. So what term shows up here? We're not worrying about positive and negative, just the term. Deborah? Say it loud.
4x squared.
Mistake. Ticket though. What term shows up here? When we're just multiplying. Yeah, I know what you're saying. I got it now. Let's go, Mikhail.
5x squared.
5x squared shows up here. Sorry, I kind of misled you, Deborah. How many knew that? 1 more. What term shows up here when you're foiling it out? What term's going to show up here when you're foiling it out? Let's go, Seth. X squared shows up there. How many knew that? Good. What term shows up here? 4 tickets. Yes, the 5 minutes. Parents. 1. Good word.
Yes.
I
do that.
Okay. Everyone who knows this answer now. These 4 things must add together to create this. These 4 things combine and they become this. Therefore, it should be clear that these 2 must add to create negative 4x squared. So raise your hand if you can tell me, are they both negative? Are they both positive? Is one positive? Is one negative? Is one negative? Is one positive? Who knows? Let's go random.
Last one. Negative because of 5x squared. Yes.
How many knew that? 4 more tickets. And then the last thing is, we now say, so now here's, look here. Okay, the negative 5x squared, you go back over here and you say, okay, was it these 2 that created negative 5x squared? Was it these 2? Raise your hand if you know. What created the 5x squared? Like multiplying what here created the 5x squared? Let's go, Ellie.
5x squared is the first of 1.
Nice. So these 2 multiplied to create 5x squared. So Ellie, this is already positive. We need a negative 5x squared, so this must be negative. Good question. Similarly, oh yeah, please.
So why can't, like, it probably, like you just said, ignore the negative, but we brought it down. I know, like, why can't we just bring the negative in the first place?
In the first place?
Just like, there's an example where like it wouldn't be negative, just because it's a negative, it's negative 5x or.
Let me do a different one in a second that will help illustrate that. Then here, Derek, answer this. So what created the x squared, Derek?
The 1 in the x squared.
Good. And this is positive. This is already positive, so is this positive or negative?
Positive.
Good. Then the final check is this times this is supposed to be -1 and
Oh, okay.
Boom. Please.
So that one is like it was easier to do because that's a 5, 5 and 1, and then 1 is 1. So if it's like a 6 and 6 again, how would you do that?
Great question, Sarah. Let me flip to a new page here. Hold on a second. Okay, first of all, I will give you this caveat. Rich, you know what caveat means? Apparently not. Okay. Sorry, I don't mean to use words that are, anyway, never mind. Okay, all caveat means I'll give you this exception. This kind of little warning. The method I'm showing you doesn't work really well for very, very complicated factoring, where there are many, 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 many choices. The other methods you learned work better. They're just hard to remember. Good news on the AP test, though, I've never seen them give you a really difficult factoring question. I think the worst one I've seen was one that was on the homework a few days ago. It looked like this. It was 3x squared minus 8x plus 2, I think. I'm not sure if that even works. Hold on. No, it wasn't. That was plus 4. Nope, we went down. Yeah, that works. So I do the same thing again. But this will illustrate kind of your question, Sarah. So I say 3x is x. And yes, it gets a lot harder, Sarah, when there's more than one choice for this. But if I've never seen them have one where there's more than one choice for this. So of course this year they'll have one, but they haven't for how many years? Since 1969?
A lot.
It's fairly safe, So they still could, but they haven't since 1969.
Yeah, what do you mean by
Like if this were equal to 6x squared.
Oh, where you can do.
Yeah, this could be 6x times x, or it could be 2x times 3x, or it could be 3x times 2. Yeah, that gets a lot harder. So I kind of said, well, I'm going to just take my best chances and say, they never asked that difficult, so rather than spend a lot of time teaching you something hard, we'll just kind of show you the easy way and hope that it works out. It always happens. Now this one does have 2 choices, so watch. So you may have said, let's put a 4 and a 1. Okay with that? And then what happens is, Sarah, when I start checking, I figure out pretty quickly it's not going to work. Because I say this times this is 3x squared. Keep talking, Sarah. This times this is 12x. This times this is, sorry, this one is 1x. I just stop right there, Sarah. Can you add these 2 together to ever get negative 8x? No, so that was the wrong choice. So I just do a different one. And I say, well, maybe it was this way, Sarah. So I just switch places.
I was going to go for 2 and 2.
It's still 3x squared. What's this one? What's this one? If you tell me, will that work to get that? No, so it's not that one. So 2 and 2 work.
Yes, I'm talking about.
Does that kind of answer your question, Sarah?
Yeah.
And honestly, when you do it the first time, Sarah, it feels like it's taking a long time. But with just a little bit of practice, you can see fairly quickly. You can start to do the steps in your head without writing them down. So. Good.
To factor it like this, you have to have the x squared, and then the x, and then constant, like the x equals, and then x squared, and then constant again.
You do. That's perfect, Victor. Anybody else on this one? Anybody else have a question back here? Yep. is everybody good to step 4?
Yeah.
4 is right here, for your fish. So look at the sign chart. We just, oh, please do, I have a question.
So, probably really dumb.
No,
but-
it's not.
So you know how you're like, and you're like, which one should we focus on first? You know, the 5 fourths. Why don't we do anything for -4x squared, and then it ends up working out?
Outstanding
I'm
question.
just kind of confused. I'm like,
No, that's not it. That's a very good question. You can answer it. I'll give you the reason why. Tell me, Derek, did things multiply or add to create this one right here?
multiply.
Multiply. Did things multiply or add to create this?
Multiplied. Right. No.
They actually did both. Because, no, you're okay, look. This came from multiplying these two,
Okay.
and then multiplying these two,
Oh.
and then adding them.
Okay.
You see that?
Yeah.
So because that operation is far more complex, it's a lot tougher to figure out what that one is.
Okay.
So I find the easy one first.
Uh-huh.
That makes finding the harder one much easier. If
Okay.
you start looking for this one first, it's a lot harder.
Okay.
There's just too many possibilities. In fact, there's an infinite number of possibilities that will make this happen.
Okay.
There's only one possibility that will make that
Yeah,
happen.
so is there ever, so you always want to do that?
Always focus on the last. There's never an exception.
First and last.
Never an exception. Always first and last. Please.
Then I understand, like, again, like, not the reading the 5x squared plus 1 to get like the zeros. But 5x squared plus 1, you got to be square root of 1 over 5. And it's square root of be positive or negative. But how's it always positive?
Positive. You look here. This was wrong. This was somebody's idea.
So that's wrong.
Yeah, this is wrong. So just look
That
up.
would make sense.
No, you're fine. What is the square root of 1 over 5 squared?
1 over 5.
It's positive 1 over 5.
Yeah.
So then what would 5 times 1 over 5 be?
1.
Plus 1 would be 2. Good. So then we tried negative root 1 over 5. Well, when you square a negative, do you get a positive or a negative? You get a positive, so you still get positive root 5. So 5 times positive root 5 is still 1. 1 plus 1 is still. Yeah. So it doesn't work.
Okay.
Never have a zero.
It's the same thing I was doing with, I can't remember, it was Chad I was doing it with. So
Yeah.
I heard somebody saying they'll never have a, whose voice was that? Yeah, say here, Sarah. Try this, Sarah. Remember, the x value can only be one of 3 things: positive, negative, or 0. So let's write this down. Let's take 5 times a positive number squared plus 1. Sarah, will that be positive or negative? Okay? This word wrong here is kind of a misnomer. It's just showing what those things are. That's actually right.
Yeah.
So confusing. Okay, so let's try the other possibility, Sarah. Let's put in a negative number. What do you get?
Positive.
The only other choice is what, Sarah? 0. What do you get? Positive. That makes sense?
So if it's ever something like x squared, plus something, it's always positive.
You have to be a little careful just because there's too many different situations. So it's hard to say always.
What if you go through those steps?
But if you check this, you're safe.
So
Because there's
like,
no, you know.
when I think of trying to write like the zero of it, like I need to do change thing.
So do this, that's okay, let's do that, Ellie, look. 5x squared plus 1 is equal to 0. So 5x squared is equal to negative 1. So x squared is equal to a negative 1/5. Okay, right there you should stop and ask yourself something. Can you ever square a real number and get a negative value? No, that's why you know there are no real numbers which will cause this to equal 0. There's an imaginary number, but not a real one.
Oh, okay, that's why I was like, should you get I in there?
Right, but no real, we just only real numbers for our problem.
Okay.
Does that make sense?
Yeah.
So Sarah, this is another way you can just do it. But you do have to get to here and say, yeah, there's no real number that you can square and get a negative value. So. Please.
Can we just like take the square root of both sides and then that
You
would-
can, but then you get an imaginary number. Anybody else?
Will we ever have to deal with imaginary numbers?
Not in our class. Calc 1, 2, and 3 landed no imaginary numbers.
I hate.
I never had Calc 4, so I don't know.
And maybe it's imaginary, you know?
There you
Real.
go. Much of electronic circuit theory, a lot of it is based on using complex numbers. So I did lots and lots of things with complex numbers, but I never took a calculus class using complex numbers.
But you do it.
You didn't even need a class.
Self-taught. I wouldn't even be surprised.
Inventor.
I'm gonna take a class and use my exam.
Yeah, you can.
I invented
you
it,
can trust
actually.
I'm very efficient. I really try to make the practice test as small as I dare make it, and still feel like I'm giving you a good representation of all the concepts you need to be remembering. Yeah, I really try to get away from redundancy, and every question is picked pretty carefully. Like if you find a question, you're like, oh, Mr. Smith, these feel like they're the same question. I usually can point out to you, yeah, but did you notice this little difference? You go, oh, and I go, yeah, that's why I gave it to you. Does that make sense? Good. The thing is, hopefully, it sounds dumb to say this, but I hate pretend learning. I like real learning.
Yeah, same here.
Like, I hate the idea that we do a bunch of stuff and you go, why did we do all that? Well, we had 90 minutes to fill, so we had to do something. I hate that.
Yeah.
Like, it really drives me crazy. I tell students all the time, if I'm giving you busy work, you've got to tell me, and I'll stop. If you really can, if I can't give you a good reason, you go, oh, that makes sense, I can see why you did that. Then we'll just eliminate it.
Yeah.
Yeah, I'm not a fan of that.
So I think the test is busy work.
Yeah. So here's the answer. What's the goal? What's the goal of the class? To pass the AP test. Did I answer your question?
Yes.
Check it.
I think grading is something that
So what's the goal of the test? What's the goal of the class? Pass the AP test.
That will always be the answer.
Is the AP test going to be graded? Okay, now answer. Now answer this. Look, listen. Okay, you know yourself. You know yourself. If I did not grade the test, if I simply said to you, do the best you can and it's good enough, how much effort would you really put into the test?
0.
Thank you. And the story.
Not very much.
I was like, I'm just like you. Same thing.
You don't give us that even check.
I do it every.
I'm a bit of a fanatic because I really like answering questions so much that if I could find a way to make sure my family was provided for, I may still come to work if they didn't pay me. I'm serious. Like, I really like answering questions. I really like this interaction a
What?
lot.
I
Now, that's
like it
dead honest
too.
truth.
How's you?
A dead honest truth. If I can find a way to provide for my family, now, I gotta have some money, you know?
Just a burden.
So, yeah. There's just a,
So if you won the lottery tomorrow and
Oh, that's an
like
interesting question.
you could pay for all of your like family's needs, would you still come into Lone Peak to teach?
I don't think I would do 7 periods.
Okay.
But I think I think I would still come. Like maybe do like a half a day, or like every other day, to have just a little more free time, you know what I mean? But no, I'm serious. Like, I don't like,
You're 80 years old.
I don't like presenting.
Yeah.
I don't. But I love answering questions. And like today is a really good example of that, where like I just feel you like probing for like, hey, what about this situation? What about this one? I love doing that because I don't know, I just love the fact that I can see your minds are growing.
Yeah.
And it's gonna, now look, you probably will never use calculus, most of you.
Thank
I-
you.
Yeah, I won't.
Yeah, I'm under no illusion, okay?
I can so happy that you
Okay, but, Landon.
You're gonna be calculus teacher.
Probably should turn off my recording. Listen. Okay. But I do know this. The world is changing very rapidly. I've told you this before. It is it's just a dead honest truth. There was an article in the paper a little while ago that said, you know, the candidates running for president, Hillary Clinton, Donald Trump, were both saying, we're going to bring back jobs to the United States, blah, 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 right? Manufacturing jobs.
Blah, blah, blah.
The article said something very interesting. They said, honestly, since the 70s, the amount of manufacturing being done in the United States has like doubled or tripled. We're not losing manufacturing jobs to other countries. We're losing them to machinery.
Yeah, exactly.
Does that make sense?
It was one of my, it was actually my calculus tutor who told me that like it's kind of useless after you pass the AP test because you have computers that can just solve these kind of stuff just like that, you know.
True, but the trouble is this. Right on.
That computer.
You're right on. The difficulty is this. Calculus is a really good way to teach you, at least get started, how to think logically. Okay?
Never done it before in our life.
Okay? No, you haven't. Okay?
Thanks.
It's really true. Like when I started electrical engineering at BYU, they passed out this document that explained, here's the goal of your major. You're going to spend the next 4 years doing this. Here's what we're trying to accomplish. The first line of the document said, we are here to teach you how to think logically. Unfortunately, we can't just give you a class on how to think logically. Your brain just won't respond. So instead, we have to give you all these classes like calculus, physics, engineering, that force your brain to evolve.
Brady, you have no idea.
Okay? It's really true. Landon, it's why engineers who become lawyers are some of the highest paid lawyers in the world. Yeah, they're patent attorneys. It's a really tough job to do because you have to have an undergrad major in engineering and then you have to go to law school. But they'll pay you a lot of money because very few people can do it. Anyway, this one, Oakley, is this you?
Brady.
Oakley?
Yeah.
Here
This
we go.
physics coming together into one, and that's what I
Hey, quiet again. No one talks. No one. Look like it. No one talks. Come back. Come back. Come back. Come back. Okay, you all thanked Oakley after the test because, as I just said to him, I didn't put this on randomly. I put it on because I know there's like 1 or 2 questions on the test that deal with the relationship between position, velocity, and acceleration. Again, it doesn't mean you're going to have a question on the test that's a mirror image of this. I'm sorry, that was all the classes you took prior to calculus, okay? Not this one. But you do have to have this relationship memorized. We have position, the derivative of position, which has another name, velocity. The second derivative of position, which is the derivative of velocity, which is also the acceleration. And I've even seen a question where they said jerk. The third derivative of position. They never use the word jerk in AP calculus, so you don't have to worry about that.
That's what it's called.
It's what it's called. It's what it's called.
And then it's snap, crackle, and pop.
Yeah, he's correct. He's correct.
Wait, what?
AP physics.
So-
We talked about it yesterday.
Yeah.
Blew my mind.
So the
Call
rate-
someone a jerk.
So the rate at which the position is changing, as Landon said, is known as the velocity. The rate at which the velocity is changing is called the acceleration. The rate at which the acceleration is changing is called the jerk. The rate at which the
Idiot.
jerk is changing is called the snap, crackle,
Yeah.
pop. Okay, cool.
Why?
And the guy-
Derivatives of
It's like
position.
all
This is
scientific,
also
and
having
they
sense
started-
of humor, you know.
Whoever was making this was like thinking, and they started eating breakfast cereal.
Pretty much. Some phys- hey, I got it!
This is the exact
Rice
conversation we
Krispies.
had yesterday, but a lot more.
Yeah, wait, I can't tell if you're being sarcastic or serious.
I will stop.
It's
I will stop.
Wait, what?
Stop. 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 Okay, please. Sarah. Mark down 10 tickets. Right now. No, I'm serious. Listen.
Can I too?
No. Listen. Quiet. There's a reason why I'm giving her 10. It's because all year long I'm trying to promote the idea that no matter what we are talking about, if it gets uncomfortable or unfamiliar or you can't tell, you just speak up. That's what I want you to do. Does that make sense? That's what I want you to do. Hey.
Eli. He
I don't
signs the
know.
board every time, every class.
Sorry, that's-
Yes, every time.
Okay. I got distracted. Okay, so Sarah, the truth is this. For your test, you must know this relationship right here. Okay? You don't need to know the name over here that is really called the jerk. Don't worry about that. Just delete it from memory. You don't need it. And then this thing about if you keep taking more derivatives, you get what's called a snap, the crackle, and the pop. It's actually true. It sounds kind of stupid, but that's what they named them. But you don't have to know that. Does that make sense? So I wasn't being sarcastic. Those actually are the real names. But you just don't need them. Are you good?
Yeah.
Good. Look up. Hey. So this is a particle moves along the x-axis. The position is given by this formula. At what time is the particle at rest? Hey, when you're working on the practice test, you must be always concept focused. Okay? What AP test writers like to do, and remember, all I'm giving you are different AP problems that you have never seen. Okay? So what they're going to do is they're going to read this problem and they're going to say, okay, let's get one that's similar but different. Just stay focused on the concepts. You can find your way through the problem. We need to know this answer. I'll pay 3 tickets for everyone who knows. What's the indicator that tells me the particle is at rest?
Velocity equals 0.
Nice, no hand, but true. So I need to figure out when the velocity is 0. Does anyone have a question about that? Memorize that statement. Particle is at rest means the velocity is 0. Memorize that. Particle is at rest means the velocity is 0. Take the derivative of position to find the velocity. I'll write down the position here again. I'm going to give you a golden hint. Listen close. Listen close. This happened on the Unit 1 test as well. I had you write a flashcard that said something like, if they ask you to solve for some constants like A, B, K, okay, don't worry about it. Just do what you always do. Pretty soon the answer will appear. Like, don't get stuck worrying about the constants. Just kind of do the regular stuff. The values will appear. Now here there's no A, B, or C, but that's why it's called a golden hint. Wink, wink. Okay, moving on. You didn't understand that? Oh well. So we take the derivative, so we get 6t squared minus 42t plus 72. We need to figure out when that's equal to 0. So this is back to Sarah's question. This actually fits perfectly with what you asked earlier. I need to figure out when this is equal to 0. This has a special name. It's a quadratic. You need to factor. But don't look, Sarah. This would be a very difficult quadratic to factor as written because there are several ways to create 6 by multiplying. Take out the 6 first. Boom! Nice.
Punch.
I learned not to.
You started to think logically.
That's right. Takes a lifetime to do that. Takes a lifetime. Sarah, I'm going to keep giving you tickets. You're doing such a good job today. Sarah, what multiplies to make t squared?
Dad.
Okay, tell me. Right. Sister channel to TBS. All right. Sarah, what multiplies to make 12? So let's just do this one in our head, Sarah. So these two multiply to make, say that, 3t. these two make 4t. So in 3t and 4t add to become 7t.
Yes.
As long as they're both negative. Does -4 and -3 multiply to make 12? We're done.
Holy cow.
So let's see. Article is at rest.
Why couldn't they teach us that way like 2 years ago?
They did.
They taught it in some weird.
They like do the square and the square and stuff.
What do you mean? I guarantee you've done it that way. Don't remember. We did it.
Here's my editorial comment. In my opinion, the classes prior to calculus, they should spend more time helping students get really, really good at this and much, much less time learning those more complicated factoring methods. Okay, I'm just taking time from my experience. In college, I took Calc 1, Calc 2, Calc 3, partial differential equations, partial differential equations. I learned linear algebra on my own. I took physics 1, 2, 3, and then solid state physics. I took chemistry 1. I took 60 credits of engineering classes. All those classes, Jackson's passing out. Okay. Listen, all those classes require lots and lots of math, right?
Yeah.
I never ever had to do those complicated factoring. So why are we teaching them in high school? Just my opinion.
What math did it, what was the highest rank
What else
in
was
high
it?
school?
They didn't have calculus, so the test I took was like your secondary degree class.
What?
You just like crushed
So
it.
we have to.
Just give me the mic.
You'd probably be up to like walk with
Yes.
Just that's not.
Right.